is gone, we've only begun. That's the best part, when we get it on. I'm addicted, no denying it, 'cause you don't cross my mind, you live in it. I wanna taste you and feel you shake, raising an earthquake. Can't push the brakes when a rush hits. We're going in, we're going in. You keep me biting my cheek, year after year. Only gets better, I'm weak in the knees. We hit the sheets, you on my lips, I'm feeling the heat. That's all I need. Ah, 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 ah.
Get yourself a freaking lit dude. In the mood 24/7, 6911, so you're making it, but I'ma just stop.
चलो गाना बंद
For a
करें,
moment.
आगे देखते हैं। तो हम ये देखे, हम ये किए थे ना लास्ट टाइम, सबमिट करने वाले थे। तो अगर हम इसका एक टाइम कॉम्प्लेक्सिटी निकाले तो क्या चल रहा है यहाँ पे। हर एक को अगर इसकी टाइम कॉम्प्लेक्सिटी की बात करें तो हम यहाँ पे एक नंबर को ट्रेड कर रहे हैं। फिर लाइक यहाँ पे चेक हो रहा है, ये कंडीशन है, तो ये कंडीशन सेटिस्फाई होगी तब। नहीं हो रही है तो 1 तो रिटर्न होगा ही, लेकिन सबको तो चेक करेंगे। ये बेसिकली एन टाइम्स होगी, और ये कब होगा, ये एन टाइम्स होगी। तो ऑर्डर ऑफ क्या, एन स्क्वायर होनी चाहिए। चैट जीपीटी से पूछते हैं। सेट इनिशियलाइज किया, इटरेशन थ्रू सेट इज ऑर्डर ऑफ एन, इफ नॉट मीन worst case is ऑर्डर ऑफ एन। लेकिन वर्स्ट केस में क्या होगा कि अगर एक भी एलिमेंट मैच ही नहीं कर रहा, वर्स्ट केस में टाइम कॉम्प्लेक्सिटी ऑर्डर ऑफ एन होगी। वर्स्ट केस में ऑर्डर ऑफ एन स्क्वायर स्पेस कॉम्प्लेक्सिटी ऑर्डर ऑफ एन। ऑर्डर ऑफ एन what is the intuition and approach, the institution and approach here। वाह, चैट जीपीटी तेज है, काम कर देता है ये। इंस्टीट्यूशन ये रहा, ये अप्रोच रहा, ये टाइम कॉम्प्लेक्सिटी, ये स्पेस कॉम्प्लेक्सिटी, समरी, ये रहा कोड। ये लॉन्गेस्ट कंसेक्यूटिव सीक्वेंस हो गया। ये नाइफ अप्रोच कोई पूछे तो नाइफ अप्रोच ये है। बेस्ट अप्रोच नहीं होता कुछ, ऑप्टिमल होता है, ऑप्टिमल अप्रोच। ठीक है, शॉर्ट कलर्स करते हैं। नाइफ अप्रोच, ऑप्टिमल अप्रोच। ये हो गया, शॉर्ट कलर्स देखते हैं। Given a array nums with an object colored red, पराग ऑनलाइन है क्या? Given an array nums with, क्या बोला? Short colors ये बोला, given an array nums with an object colored red, white और blue। ये बोला एक array nums दिया होगा, विथ एन ऑब्जेक्ट के साथ जिसमें कलर है रेड वाइट और ब्लू. Sort them in place. Sort them in place मतलब in place मतलब without creating another array, same array में, so that the object of the same color are adjacent with the colors in the order red, white and blue. You use it to represent 0. Given an array names with an object, एक नाम दिया हुआ है जिसमें n ऑब्जेक्ट है, इसमें n ऑब्जेक्ट है, कलर है, ऑब्जेक्ट के कलर हो सकते हैं रेड वाइट और ब्लू. उनको बोल रहे हैं सॉर्ट देम इन प्लेस. इन प्लेस मीन इन this means in the same array without creating duplicate one. And this means this is without creating a duplicate one. तो चैट जीपीटी से वेरीफाई कर देता हूँ. It means the operation will be performed with directly with the same data type and not another data is another element by the input array. 'Mm, in place. Sort them in place so that the object of the same color are adjacent with the color in the order red, white or blue. We will use integer 0, 1, 2 to represent 0, 1, 2. Red, white, blue. 0, 1, 2, 0, 1, 2. ऐसे भी शॉर्ट कर सकते हैं. ये ऐसे बस कर दे अगर हम तो वर्क हो जाएगा. पहले ना इसको उठाते हैं, इसको लॉन्गेस्ट कॉन्सिक्यूटिव में आते हैं. शॉर्ट नम्स कर दे तो मेरे को लगता है इसी से हो जाएगा काम. मजाक मोए मोए हो गया प्रॉब्लम का. बट ये बोल रहा है could you come up with a one pass algorithm without using constant extra space. हाँ, बट ऐसे तो करना नहीं है, प्रॉब्लम बोल रहा है तो एरर डॉट शॉर्ट तो यूज कर नहीं सकते. We will use integers 0, 1, 2 to represent the color red, white and blue. You must solve the problem without using the library short function. Input nums 202 110. Yeah, मैं input 201 तो आउटपुट होगा 012. अगर बेसिकली मुझे ऐसे सोचना हो ह्यूमनली अप्रोच तो क्या कर सकते हैं. मेरे पास है 202 110. तो अगर हम पहले ऐसे ही बेसिक अप्रोच देखते हैं ब्रूट फोर्स वाला. तो अगर हम नाइव अप्रोच देखें तो हमें शॉर्ट करना है ना. नाइव अप्रोच में क्या होगा, हम कोई सॉर्टिंग एल्गोरिदम लगा देंगे. मर्ज शॉर्ट ही लगा देंगे. तो लाइक अगर मर्ज शॉर्ट लगा दे, इफ वी अप्लाई मर्ज शॉर्ट, लेकिन ये है ना मर्ज शॉर्ट में हमें क्या नया रिजल्ट एरे लेंगे और रिजल्ट एरे लेके उसमें स्टोर करेंगे आंसर्स बेसिकली. और फिर हम सारे रिजल्ट एरे से सारे एलिमेंट्स को उठा के नम्स एरे में चेंज करेंगे. ठीक है, नाइव अप्रोच में ये कर सकते हैं. इफ अप्लाई मर्ज शॉर्ट अप्लाई कर सकते हैं. मर्ज शॉर्ट कैसे लगाए थे हमने. मर्ज शॉर्ट बेसिकली उसको दो टुकड़ों में डिवाइड एंड कॉन्कर अप्रोच है, उसको दो टुकड़ों में तोड़ते हैं और फिर ये रहा मर्ज शॉर्ट कॉल किया, उसको दो टुकड़ों में तोड़ते हैं मर्ज शॉर्ट फंक्शन. एक मिनट से आगे तक चलेगा, फिर मर्ज फंक्शन कॉल करते हैं. तो बेसिकली सारे एलिमेंट्स को मर्ज करते हैं. हम टेम्परेरी एरे बनाते हैं. स्टार्ट होता है जे इक्वल टू मिड प्लस 1 के. अगर आई मिड से छोटा होता है तो ये भी कर सकते हैं हम. आई अगर मिड से छोटा हुआ और जे एंड से छोटा हुआ तो नम्स आई अगर नम्स जे से छोटा हुआ तो उसको हम आगे स्टोर करते हैं और के को बढ़ा देते हैं. फिर सारे एलिमेंट्स को कॉपी करके इधर डालते हैं, फिर जे के सारे एलिमेंट्स को कॉपी करके इधर डालते हैं. फिर हम क्या करते हैं, जो नम्स एरे है मेरा उसको उसको पॉपुलेट करते हैं स्टार्ट प्लस k2 दैट इज स्टार्टिंग इंडेक्स ऑफ द रिजल्ट एरे. और टेम्प में हमारा जाता है, टेम्प से वैल्यू उठता है और नम स्टार्ट प्लस k2 हो जाता है. ओके. तो मर्ज शॉट हमारा यही करता है. देखते हैं ये इन्होंने कैसे किया
Hey
था.
everyone, welcome back and let's write some more neat code today. So today let's solve sort colors. This is a pretty good problem. I actually really like this problem. We are given an array of nums and they give us a little bit of a description, like each value in nums is a color, but let's just skip that because I think it just kind of makes things a little bit overcomplicated. So let's think of it simply. We are given an array of nums n values in this array. Any of the values could be of three different integers. Each value could be a 0, 1, or a 2. We want to take this array and then sort it in ascending order, right? So let's say this is the input array. We want it to be in ascending order, zeros first, ones next, and then twos, right? Pretty straightforward, but there's many different ways you can solve this problem with varying efficiencies and varying memory complexities. So now they tell us right off the bat we can't use like a library sorting function because of course library sorting functions run in n log n time, and it would just be a single function call, just call sort on this array. But I guess we could implement our own sorting function, which would also end up being n log n, whether you do
Yeah,
merge sort
merge sort.
or I think quick sort also has the same average time complexity, right?
Hmm.
So we could implement our own sorting and then do it in n log n time, but we can see that this problem is a little bit more simple than just a regular sort.
Hey everyone, welcome to the channel. If this is your first time here, my name is Derek and I cover Python.
फिर मैं भटक गया, कुछ और करने लगा. यही होता है.
Sorting problem because we are given only 3 values in the array, only 3 potential values. So if you've heard of the algorithm bucket sort, then right off the bat, you're going to think, yeah, this problem can be solved with bucket sort in linear time. We can sort this input array in linear time. Reason being is we know that there's only 3 different buckets. If the values ranged from 0 to, n, where n could be an arbitrarily large value, then of course we could not do this in O of n time, but we know the values are only going to be between 0 and 2. We can do bucket sort. Now, what is bucket sort? And how are we going to use it to solve this problem in linear time? Well, we're going to say we have 3 buckets, a 0 bucket, a 1 bucket, and a 2 bucket. And for each of these buckets, we're simply going to scan the input array and count how many of each of these values occur in the array. So yes, we are going to need extra memory, but really this is just going to be, let's say, a hash map or an array of size 3, right? This is just going to be an array of size 3. So we'll count how many 2s. So we have a single 2 so far. We have a single 0. We have another 2. So let's say the number of 2s is 2. then we get 2 1s. So yes, we have 2 1s, and then we get another 0. So in reality, we have 2 of each of these values. Now we want to build the output array, but we are not going to create a separate output array. They want us to do this in place. We can see up above. So what we're just going to do is, since we know we have 2 zeros, let's just go at the beginning first 2 values, cross these out, replace them with 2 zeros, just like in the output array. Again, we're going to, so now we're done with the zeros portion, right? We took 2 zeros, put them at the beginning. Next, we know 1s go right after zeros, so we're going to take these 2 1s, cross out these 2 values, right? And then add 2 1s right after the zeros. And the exact same thing with the 2s, right? We have 2 2s, so that's going to make up the remaining portion of the array. We can place those 2 2s at the end, right? So we're overwriting this memory, so we're not actually using extra memory or anything. So this is a O of n time solution and O of 1 solution. This solution, in terms of complexity, is about as good as it gets, but this is such a trivial solution that I'm actually going to show you the slightly more hard solution, which is actually the one-pass solution. We can see in this case, we actually did have to go through the entire input array twice, once to create these buckets, and then once to actually build the output array, but we can technically do it with a single pass, which is a slightly harder solution. That's what I'm going to show you today, and that's what we're going to code up. So before I show you the solution, my first question to you is, have you heard of the algorithm Quicksort? In particular, do you know the portion of Quicksort that requires the partition algorithm? Do you know how to partition an array? For example, let's say we had an array and we wanted every single value, n value, which is less than 5, to go in the left portion of the array. And if we did that, let's say we had an array of 1, 2, 6, 7, right? These values, we wanted the values that are less than 5 to go in the left portion of the array. If we did that, what does that mean? Well, that means we took these values, put them in the left portion of the array. Now, if we did that by swapping values around, if these 2 values are over here, and let's say the size of the array is 4 values, these original 4 values, if we took these and put them in the left, that means by default, these 2 values, which are greater than or equal to 5, are going to go in the right portion of the array by default, right? That's called partitioning an array. That's the same idea we're going to use here. So remember how we want the zeros to go at the beginning, we want the 1s to go in the middle, and 2s to go at the end. So let's partition the array using the same idea. We're going to go through every single value in the array, right, in the example array, let's say, and every time we get a 0, the way this partition algorithm works is we have a single pointer at the left, right? It's basically, we're going to call this, let's say, the left pointer, right? It's designated beginning all the way at the left. We're going to have another pointer, I, which is just going to be running through the entire array. Anytime we get a 0 value, we're going to take that 0 value, let's say it's from over here, we're going to take that 0 value, swap it with the value that's over here, right? The value that's over here is not going to be a 0, right? So whatever it is, maybe it's a 1, maybe it's a 2, either way, we're going to swap it, put it over here, and then that 0 is going to go over here. So then once we have a 0 value here, then we can take our left pointer and then shift it over here, right? Because then we know that the next time we encounter a 0, we want to put it in this position. Now, of course, what happens if the first value by itself already is 0? Then we're going to end up swapping it with itself, which is perfectly fine, and then we're going to take our left pointer and then shift it here anyway. So it works out in both cases. So let's say we do that. Let's say we run through the entire array. What's our array going to look like? Well, in this example, we'll have 2 zeros being at the beginning, but then we'll have the remaining portion just being some 1s and 2s in some arbitrary order, right? We don't know about the order of these. So we successfully partitioned the array. We got all the zeros at the beginning, right? This is one partition. Now we still need to partition this, right? We need to put both of these 1s at the beginning and then take all the 2s and put them at the end, right? But remember, if we do it like this, then we are doing 2 passes, right? It's technically allowed, but our target was to do this in a single pass. So let's maybe try to modify this partition idea. How about we take all zeros, put them here using our left pointer, but why not have a second pointer, which is always going to be at the right, let's call it our right pointer, and then anytime we encounter a 2, we put the 2 over here. Anytime we encounter a 0, we put the 0 over here. We shift our left pointer accordingly. If we end up putting a 2 here, we take our right pointer and shift it accordingly to the next position. So this idea is definitely going to work, but there's just one edge case we have to worry about, and let me just show you that edge case. Let's say we got to some random scenario where our left pointer is going to be over here, designating to us that everything to the left over here is already a 0, right? That's of course what the left pointer is going to tell us. If it's over here, that means everything over here is going to be a 0. That makes sense. And our right pointer is going to be over here, which is going to designate to us that everything to the right of it is supposed to be a 2, which makes sense. That means there was some arbitrary 2 that we found in the array. We moved it over here, and then we took our right pointer and then shifted it by 1 over here, right? And every time we encounter a value, like we have our I pointer over here, we're going to put this wherever it needs to go, and then we're going to shift our I pointer to the next position, right? But there's one thing that we have to worry about. Take a look over here. Our left pointer could be pointing at a 1 value, right? Because if we encounter a 1 value, we're just going to skip it, right? Then our I pointer could be over here. Let's say our I pointer is here in this example. Our left pointer, yes, could be pointing at a 1, but notice how our left pointer is never going to be pointing at a 2, because if it was, we would have already swapped it and put it towards the right, right? Because see how our I pointer has already passed this position, so if it was a 2, we would have already swapped it over there. Since it's not, that must mean it's always going to be a 1, which is good for us. But you'll notice with the right pointer, everything to the right over here is going to be a 2, but the right pointer could be pointing at a 0, or it could be pointing at a 1, or it could even be pointing at a 2 maybe, right? And if it's pointing at a 0, that's going to be this out of the pointer, because our left pointer is only going to be pointing at a 1 value. So if we take a 1 value and then introduce it into the middle of our array, that's perfectly fine, because 1s always go in the middle, but we can't take a 0 and put it in the middle. That's not going to work. So that was a pretty long explanation, but I hope that you do get the idea. The code is going to be a lot easier. So let me just run through the rest of this example. So we encounter a 2, toss this out. It's 2 cases we worry about: if the value that we're at is either a 0, or if the value that we're at is a 1. So if nums of I is equal to, or maybe I said 1, but if nums of I is equal to 2, right? That's our right case. So in both of these cases, we're going to perform a swap, right? Since we're doing a swap in both of these cases, I don't want to write it out, so I'm just going to define a helper function up above. So we're going to pass in 2 pointers, the indices.
That's national flag problem. अरे
Hey everyone, welcome back to the channel. I hope you guys are doing extremely well. So this is another video from the Stribus A to Z DSA course. Just in case you're for the first time here, this is world's most in-depth course in DS Algo. Why do I say that? Because we are covering 456 modules. By the end of the course, you would have solved 400 plus problems in DS Algo. You can go over the entire internet, you can buy any of the paid courses. None of them will be teaching you DS Algo in such depth. One thing that I can give you as a guarantee, but the array only consists of 0, 1, 2. The two-sum problem. In this video, I'll be covering the problem sort an array of 0s, 1s and 2s. What does the problem state? You'll be given an array, but the array only consists of 0, 1, 2. Nothing else. Only these 3 integers, 0, 1 and 2. And your task is to sort it. I might be thinking, it's an easy problem. No, it is not. When you'll hear about the most optimal solution, your mind will be like, wow, So what's the first solution that you'll give to the interviewer? That's definitely the brute force solution, and we know what is that. That is to use any of these algorithms. If we end up using merge sort, it will take a time complexity of n log n, and it will take a space complexity of big O of n, which is the temporary array that we use during the merge sort. If you do not know merge sort, I've already made a video on that. You can go back and watch it. Obviously, the interviewer will not be happy with n log n time complexity and the extra space that you're using. So he'll ask you to optimize it. That's when you'll be telling the better solution. Now, what is the better solution that comes up? Now, something I can say is, hey, listen, one thing I know for sure is the array contains 0, 1, and 2. So what I'll be doing is, I will do a single iteration and I'll keep three variables, count 0, count 1, and count 2. And in all of the iterations, so when I reach 0, it's a 0. So I'll increase it by 1. Then when I reach 1, I'll increase this by 1. When I reach 2, I'll increase this by 1. When I reach 0, I'll increase this by 2. And eventually I will keep on going and I'll reach the end of the array. Once I've reached the end of the array, the count 0 will be containing the number of zeros, the count 1 will be containing the number of ones, and the count 2 will be containing the number of twos. In this case, the count 0 will be 5, count 1 will be 4, count 2 will be 3. So once you have done this, what you can do is very simply run a loop from 0 to 4, because we know the first 5 places will be occupied by 0, because if you are sorting an array of 0, 1 and 2, the first place will only have zeros, the next place will only have ones, and the next place will only have 2. So you will run a loop which runs 5 times, and you will just manually overwrite the first 5 values to 0. Then you'll run a loop for 4 times, and you'll manually overwrite the next 4 elements to 1. Then you'll run a loop for
नींद
3
आ रहा हूँ
times,
मेरे को.
and you'll manually overwrite the last 3 elements as
नेशनल
2.
प्रॉब्लम है
Once you
यार
have done
साला. आउट ऑफ द वे जा रहा है कॉल ऑफ ड्यूटी।
On this, I can say that the array is sorted according to zeros at first, then ones, and then twos. So what I can say is the better solution will be running a loop in order to count the zeros, ones, and
ये
twos.
भी
That
सही बोल रहा है कि अगर हम क्या करें, हम बेटर सोल्यूशन रूट अप्रोच देखे तो रूट अप्रोच क्या होगा, हम एरेस को शॉर्ट sort the array with any algo like merge sort। अगर merge sort से करेंगे तो टाइम कॉम्प्लेक्सिटी एंड log n स्पेस कॉम्प्लेक्सिटी एक एक्स्ट्रा लगेगा, ऑर्डर ऑफ एन। बेटर अप्रोच देखे तो बेटर अप्रोच देखे तो हम क्या करेंगे, वी नो देर इज ओनली थ्री टाइप्स ऑफ वैल्यूज इन एरे, 0 1 2, 0 1 और 2। तो हम क्या करेंगे, वी कैन, वो क्या करेंगे, हम काउंटर बनाएंगे, काउंट 0, काउंट 1 और काउंट 2 काउंटर बनाएंगे। और फिर क्या करेंगे, हम फॉर लूप लगा के हम सबको अपडेट कर देंगे फॉर लूप लगा के।
So in case you're looking for a setup which works something like this, where the code is on the left, the input is on the right, and the output is on the right, and they're splitted across screen, and you input something and you write the code, and then you
तो हम काउंटर लगाएंगे, हम फॉर लूप, 3 फॉर लूप लगेगा, फॉर आई इन रेंज 0 to काउंट 0। बेसिकली 2 काउंटर बनेगा, काउंट 0, काउंट 1, काउंट 2, काउंट 0। और फिर हम एक और काउंटर रखेंगे, हम रखेंगे इंडेक्स काउंटर विच इज इक्वल्स टू 0। हम क्या करेंगे, फॉर आई इन रेंज नम्स ऑफ इंडेक्स इक्वल्स टू 0 और इंडेक्स प्लस प्लस सीन लगेगा, 0 टू काउंट 1 और इंडेक्स बढ़ता जाएगा। इसे हम करेंगे इसके लिए 0 टू काउंट 2 नम ऑफ इंडेक्स इक्वल टू 0, यहाँ पे 1 और ये 2। और फिर हम क्या कर देंगे, देन कर देंगे नम्स। ये कर सकते हैं, ये सही बताया भाई ने। अरे नोबल हॉस्पिटल सामने है क्या? नोबल हॉस्पिटल सामने है क्या? पता नहीं था। अच्छा। तो पहले हम ऐसे ही करते हैं। देखो दौड़ने भी जाना है, जल्दी करते हैं इसको। तो हम क्या करें, मेरे पास नम्स आ रहे हैं, तो सबसे पहले कंस्ट्रेंट्स क्या है इसके लिए? नम्स आ रहे रूम से लेके सिलेंडर के बीच में होगा, तो काउंट इंट काउंट 0। तीन काउंटर बनाएंगे। तीन काउंटर बनाएंगे। फिर हम क्या करेंगे, फॉर ईच एंटायर नम्स इफ आई इज इक्वल्स टू 0, तो हम क्या करेंगे, काउंट 0 प्लस प्लस else if I is equals to 1, count 1 plus plus else count 2 plus plus। ठीक है, अब ये हो गया, हमने काउंटर तो हम क्या करेंगे अब, जो नम्स आ रहे हैं, एक इंडेक्स डिफाइन करेंगे, तो 0 होगा, और फिर फोर आई 0 नम्स लेंथ। हम क्या करेंगे, और एंड आई इक्वल टू 0 आई देन काउंट 0 आई प्लस प्लस। क्या करेंगे हम, नम्स ऑफ इक्वल टू 0। आइडेंट कैसे करते हैं, टू लाइन कमेंट। count 1 I plus count 2 index is equal to 1 or index is equal to 2. Return nums. रिटर्न करना ही नहीं है। अरे यार हम फिर इसके बाद इंडेक्स बढ़ता जाएगा ना। ये मेरा हो गया ऑर्डर ऑफ एन अप्रोच। रूट अप्रोच बट वैलिड को
Hey everyone, welcome back to the channel. I hope you, and this will be in every 3 cross up one. I because one is here. Can you fill up a 2? Can you? Yes.
चलो ये भी हो गया, लेकिन मुझे डच नेशनल फ्लैग प्रॉब्लम डीएनएस एल्गोरिदम ये देखना होगा। तो ये मैं देखूंगा बाद में। आज के लिए बहुत हो गया, मुझे नींद आ रही है। नहीं नहीं, मुझे दौड़ने जाना है। हाँ चलो बाय। अरे हाँ, एक चीज़ मैं बताना भूल गया। मैंने ये अगर अभी देखोगे तो लाइक लॉन्गेस्ट कंसेक्यूटिव एलिमेंट पे आके मैं इसको रन करूँ तो 4 आ रहा है। और मैं यहाँ पे इस पर डीबगर पॉइंट भी लगाऊँ और डीबग करूँ तो मेरा डीबग अच्छे से काम करेगा, क्योंकि मैंने इसे फिक्स कर दिया। बेसिक अब मेरे को शिफ्ट 11 करके बाहर आना है, बाहर आना है, बाहर आना है, बाहर आना है, बाहर आना है। फिर F10 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 ये सही से वर्क कर रहा है। ये सही से वर्क इसलिए कर रहा है क्योंकि लाइक मैंने जावा पहले 6 इंस्टॉल करा था। जावा 8 का जेडीके मैंने पॉइंट करने की कोशिश की थी, बट वो वर्क नहीं कर रहा था क्योंकि इससे शायद कंपाइलर नहीं मिल रहा था। तो मैंने क्या कि मैंने जावा 8 इंस्टॉल किया। अब तो पता ही है कि एक बार जावा 8 इंस्टॉल करते हैं तो क्या करता है, वो ऑटोमेटिकली जावा 8 पॉइंट करने लगता है। जावा 6 मेरे जावा होम में था, बट वो जावा 8 को पॉइंट कर रहा था। तो मैंने ये किया कि प्रोग्राम फाइल्स में यहाँ पे होती है कॉमन फाइल्स। कॉमन फाइल्स के अंदर होता है ओरेकल, ओरेकल के अंदर होता है जावा। बेसिकली ये ऑटोमेटिकली इन्वायरमेंट वेरिएबल्स में ऐड हो जाती हैं। इन्वायरमेंट्स वेरिएबल में ये ऑटोमेटिकली एज पाथ ऐड हो जाती है। तो वो क्या करता है, वो यहाँ पे ऐड हो जाता है, तो वो ऑटोमेटिकली ओवरराइड कर देने लगता है जावा को, जावा के लेटेस्ट वर्जन को दिखाने लगता है। तो अभी हम जावा वर्जन करें तो जावा 6 वर्जन है, और जावा सी वर्जन करें तो 1.6 ही है। पहले ये 1.8 हो रहा था, तो मैंने भी जावा 1.8 इंस्टॉल किया। और इसमें क्या किया, यहाँ पे मैंने इसको यूज़ करके हम जावा रन टाइम दिखा सकते हैं कि जावा ऐसी 1.8 यूज़ करो, और कंट्रोल शिफ्ट पी करोगे तो हम यहाँ पे रन टाइम सेलेक्ट कर सकते हैं। फिर रन टाइम ऑप्शन आ गया जावा 8 जावा 6 का। तो मैंने इंस्टॉल उसको पॉइंट कर दिया। ये वर्क करने लगा, थोड़ा टाइम लगा हाँ, बट सही है, वर्क कर रहा है। चलो मैं जा रहा हूँ, बाय।